Hey guys, so today we are going to learn a very simple but very useful formula when it comes to electronic circuits. So we had our voltage divider. If you guys remember, it looks somewhat like this. You had a voltage source in series with two resistance, and depending on by changing the value of resistance, you could change the value of voltage that you get across one resistance. So the current divider rule works almost similarly. If you have a current source, and okay, let's say I got my current source right here. So if you make the current source, if you connect it in parallel with resistances in different branches, or if you have branches in your circuit, the current is going to split up. So it's going to look somewhat like this. You would have your main current flowing into this branch, and the same amount of current would flow out. And depending on the value of resistance, you would have this current split up and travel in one branch, and another amount of current split up and travel in this branch. So this is a formula for finding what is the branch current. So what is the current in the blue, and what current is flowing, what is the value of current that is I've shown in the yellow. So to find this, all you need to know is just the main current and the value of resistances, and you can easily find out what's the current that is flowing in different branches. It is very simple. But let me explain another thing. So if you have in any of these branches, the current is going to split up, and you're going to determine what's the current flowing in your branch with the value of the resistance that you have. So if you have more resistance offered by your resistor, the current in your branch is going to be less. And if you have a lower resistance, your current in your branch is going to be higher. So this is known as a branch. Okay, so this is one branch and this is another branch. So this is a two branch circuit. So you can think of it kind of like traffic. If you're on the road, you can think of this as the highway, and then you're on the highway, and then you got two you got two ways that you can take to get back on the highway. And if you have more traffic, and you can think of traffic as resistance, if you have more traffic, you're going to have probably less vehicles going in that direction, and if you have less traffic, you're going to have more vehicles going in that direction. So something very simple as the traffic analogy can be applied to circuits. It is that simple. All right, so let us see how we can find out what is the formula that we can use to find out what is the current that's flowing in our branches. All right, okay, so here I have a circuit drawn out already. So I'm gonna just write this up a little bit more clearly. This is going to be Rx, this is R1, R2, and R3. So this circuit has four branches containing resistances Rx, R1, R2, and R3. And I am very much interested in what is the current that's flowing through Rx. So what I can do in this circuit right here is, since I'm not interested in the other branches, I can just group these and write my circuit somewhat like this. So I got my voltage source V, I got my current I that's flowing here, and these two need to be connected, and I got my branch of interest, let me call it that. I got my branch of interest, Rx, with the current that's flowing through it, Ix, and the other branch, I can just simply find the equivalent resistance and call it RT, and RT is going to be R1 in parallel with R2 in parallel with R3. And any guesses on what current is going to be flowing here? So we had main current I, and we had some part of it go through the Rx, so we call it Ix. So that is one branch current that's already subtracted from our main current. So of course this is going to be I minus Ix. Alright, so it's that simple. So let's go ahead with the derivation for this. So we know the potential difference across branches is the same. So I got one branch right here, and the current that's going to be flowing through it is, according to Ohm's law, Ix times Rx. Alright? That's simple. And this is going to be equal to, so what is my other branch? I'm going to show it right here. This is my other branch, and it's going to have a current of I minus Ix times RT. Now remember, RT is the equivalent resistance of R1, R2, and R3. So if I go ahead, rearrange some terms, so I'm just gonna use black. So I'm gonna get I times RT minus Ix times RT. And if I move this here, so I'm gonna get Ix Rx plus Ix RT is equal to I times RT. And if I take the Ix, let me get rid of this. And if I take Ix out, get Rx plus RT. That is your main current times the equivalent resistance of the other branch. So your branch current Ix is simply I times RT by Rx plus RT. Alright guys, so let's go ahead and walk through this step by step. So here I have written the same circuit that I had, and our formula was, we had our Ix is I times RT by Rx plus RT. Okay, so let's go ahead and break it down and understand what it really means. So if you have a circuit and you have multiple branches, all right, and you are very much interested in finding the current that's flowing through just one single branch, so that is your current Ix. So your current Ix is a branch current. Forgive my handwriting. And your current I is your main current. So in a circuit like this, we have shown a voltage source in the circuit. We don't have a current source. So to find the main current, you're going to have to use Ohm's law and do V by R. So because V is I times R, so I is V by R. And we're going to do that in our problem next. So hold on. And RT is the equivalent resistance of the other branch. So remember, we had 3 branches that were not of interest. We did not want to know what was the current flowing through those. So I combined them. I found the equivalent resistance, and that is our RT. And that is the resistance of the other branches, the branches that you're not interested. But there's still some amount of current flowing through that. You don't want to know the current. So that is the resistance RT. And Rx is, I'm going to write it here, Rx is your branch resistance. Alright? Okay, it looks a little messy, but if you want to find the current that's flowing through a branch, and you know the main current, and you know the resistances, all you got to do is branch current is your main current times the equivalent resistance of the other branches, the branches that you're not interested, divided by the sum of your branch resistance and also the other resistances. Remember, this is just a regular sum. You're not doing the equivalence relation here. This is just adding. So if you have 1 and you have 2 here, you just do 1 plus 2. You don't do the 1 in parallel with 2. No, you're not going to do that. It's just 1 plus 2. All right. So if you know the two resistances and you know what's the main current, hey, you can easily put all the values in this formula and you can say, hey, I got this much current flowing through my branch. All right, so let's go ahead and solve an actual problem. Okay, so I've drawn out a circuit here and we got a 12-volt power supply and we got two branches. We got our 10 kilo ohm branch. And let's call this, let's show it in the blue. All right, and then we got our load that is connected here, and this is gonna be our I load. So the objective here is simply to find what is the current that is going to be flowing through our load. And the first step, if you want to use the current divider, you got to know three things. So if you go to this formula, you have to know what is your main current, you have to know what is the resistance of your other branches, and you have to know what is the resistance of the branch that you want to that you're interested in. All right, so my main current here is going to be 12 volts, and using Ohm's law, I got 12 volts divided by 10 kilo ohms in parallel with 2 kilo ohms. So that is going to be 12 divided by 10 times 2 is 20, divided by 10 plus 2 is 12. So I'm just going to keep it this way. So it is 12 divided by 20 divided by 12. Oh, wait. So I can cancel out. No, I cannot. I cannot cancel out 12 and 12 because it's 12 times 12. Anyways, so I got my main current right here. And I got my resistance of the other branch, the branch that I'm not interested. So that is 10 kilo ohms. And I got my branch resistance that I'm looking at, 2 kilo ohms. That is my load resistance. So I want to find the current through the load. So that 2 kilo ohms becomes my branch of interest, as you can call it. So let's go ahead. It's a simple substitution. So my IL, load current, is, I can also say IX is RX. That is, let me do the current first. Okay, so our main current is 12 divided by 20 divided by 12. So that's our main current. If you look at the formula right here, so that's I times RT. So our RT is 10 kilo ohms divided by RT plus RX. So that's again 10 plus 2, and this is 12. All right, so it's a lot of math, but it makes it simple because we can just cancel out stuff. And all right, let's go ahead and cancel out this 12 and this 12. And I can cancel out 10 and 20. So this is going to be 2. So I'm left with 12 divided by 2. 6 milliamperes. So my load current is going to be 6 milliamperes. And another interesting thing to watch out for is you got your load current as 6 milliamperes. All right. So if you use Ohm's law again, 6 milliamperes times 2 kilo ohms, you would get 12 volts back. So that is a way to check if your calculations are correct. So it is very easy to use this current divider formula. Also, the formula looks a little bit messy, like right here. But yep, so you can go ahead and use this very simple formula, work out any kind of problem that you have, and you can easily know what's the current flowing through your branch. Thank you for watching.